Hello and welcome to this clip having a look at some water crystallization calculations. So we're going to start with a quite straightforward example. So let's start by thinking about how we might process this. It tells us that the nickel compound has a formula and a molar mass. That basically means the molar mass of the hydrated salt, which is the NiNO3 2.XH2O, the whole thing, is 290.7 grams per mole. So processing the rest of the question, you separate the hydrated salt into its anhydrous salt and the water of crystallization. So the next thing to do after that is to apply the data you've been given to what it means. Like we said before, the hydrated salt is 290.7 grams per mole. So taking the anhydrous part and consulting the periodic table for nickel, nitrogen and oxygen, the anhydrous salt on its own is 182.7 grams per mole. So that must mean that the XH2O left behind is the difference between the original hydrated salt and the anhydrous section of it. So subtracting one from the other gives you 108. So we want to work out how many moles of H2O fit into 108. Now H2O is 18 grams per mole. So you divide 108 by 18.0 and it gives you 6. So that means X equals 6. So let's now try a slightly more complicated example. It's an exam question with some data. So taking the two bits at the top where it says massive empty crucible and massive crucible plus the hydrated salt, which is SrCl2.XH2O, the difference between them is going to be the mass of the hydrated salt. So that gives us 2.69 grams. Now we concentrate on the crucible again and the fourth mass of the crucible where the mass has actually stopped changing. So that's going to be the difference between those two, and that's the mass of the anhydrous salt. That gives us 1.62 grams. So now what we're going to do is work out the molar mass of the strontium chloride. Again, consulting the periodic table, it gives us 158.6 grams per mole. So the number of moles of strontium chloride in our 1.62 grams of anhydrous salt is 0.010253164, keeping my calculator value. The next thing to do after that is to concentrate on the XH2O. And like we did before, the difference between the total mass of the hydrated salt minus the mass of the anhydrous salt left behind is the water of crystallization. So the amount of H2O in moles in this is going to be 0.059444444, again keeping my calculator value. So we want the mole ratio of anhydrous salt to water of crystallization. So putting those two numbers in, we divide by the smallest to get the whole number ratio. Okay, so 5.79 is slightly below 6, but looking closely at what the instructions give us, it says give your answer to two significant figures. So I'm going to change that to 5.8, which I put down there as X. Now, it says suggest why the student takes 4 readings of the mass of the crucible and the residue. So reading number 1, reading number 2, reading number 3, reading number 4. These two are the same. They're both 17.58. So that tells the student that all the water has been removed. So having a quick check of the mark scheme, it says first check the answer on the answer line. If the answer is 5.8, award 3 marks. We obviously came across these numbers as we did our working, and that led us to 5.8, so we get all 3 marks for that particular part. And the second part is to make sure all the water has been removed, and then we get that 4th mark. Okay, thanks for listening. Until next time, see you soon.